How are we all doing today? Welcome back from spring break. Hope everybody had a fantastic break. We are essentially at the end of our Mod F unit, and so we are now going to work on our review. So the first 4 questions on our review are graphing. We had 2 different methods of graphing. I'm going to go through one of each, although I am going to do number 3 and start you on number 4. And the rest of this video, I will go through all of the odd questions. I encourage you to stop, pause this video as often as you possibly can to work ahead or work back, try things again so that you have the best understanding possible heading into the exam. All right, so starting with the transformation method of graphing. With the transformation method of graphing, we had 2 key points. 1, 1, negative 1, negative 1. We plot those, and we have these asymptotes running through the middle. So on the exam, you are going to have one of each of these types of graphing for sure. So make sure that you can do both of them, at least have a good start on both of them. All right, so first step after transformation, after plotting these key points, is to do our stretch. And in this case, our stretch is a factor of negative 2. So I'm going to multiply the heights by negative 2. Starting with the dot on the right, which is currently at a height of 1, if I multiply that by negative 2, my new height is negative 2. Dot on the left has a height of negative 1. When I multiply negative 1 by negative 2, a height now of positive 2. Okay, so that's the stretch. The stretch doesn't have any impact on the asymptotes at all. Grabbing my last color here, we're going to now take care of our horizontal and vertical shifts, and I have highlighted both of them for you. You see in blue. The plus 2 in the denominator shifts us to the left, and then minus 1 on the end shifts us down. So we're going to shift both of these purple dots to the left 2 and down 1. Our asymptotes are also going to slide left 2 and down 1. So I go back to the middle of my graph, right? The 0, 0, right? So I'm starting back here, right there in that middle. And I go left 2 and down 1. And I make a little T. Then I'm going to extend my asymptotes. That one didn't turn out great. There we go. Extend my asymptotes in both directions, creating my new asymptotes, and then remember, your curve cannot touch or hit the new asymptotes. We did have a square root point, which you're welcome to graph. We could do the square root of 2 here, and that would just give you 1 more point. But honestly, 1 point on each side is sufficient. Okay. So I'd encourage you to try number 2 on your own, asking Mr. H for help in class or when we get back to class together on Wednesday, or excuse me, Thursday. I will be there to help out as well. All right, so number 3. First thing I'm going to do before I really start to graph this is come up with a horizontal asymptote. And the horizontal asymptote is a comparison of the x's. So my highest power of x in the numerator is x to the first, but in the denominator it's x squared. And when there is a higher power of x in the denominator, our horizontal asymptote is automatically at 0. All right, so now we're going to move into our vertical asymptote. But before we do that, we have to factor. So I'm going to factor both the numerator and denominator. In the numerator, I'm going to factor a negative 4 out. If I factor a negative 4 out, I am left with x plus 1. And again, if any of this is confusing to you, pause it, make a note of it, ask me or Mr. H for help on that. Denominator, if you are struggling to factor that denominator, that's not going to go well on the test. You've got to be able to factor that. That's going to factor into x minus 2 and x plus 1. Okay, so recall that any factor from the denominator that cancels out, like the x plus 1s, will create a hole in our graph. So there is a hole at x equals negative 1. And remember, it's opposite. It's what would solve that if x plus 1 was equal to 0. The vertical asymptote is the factor that's left in the denominator, and again, it's opposite, so we have a vertical asymptote at 2. Grab my blue again. and draw in that vertical asymptote. All right, so those are kind of the horizontal and vertical asymptote are the two main shaping pieces of this graph. Now we need a couple of dots. So we're going to have an x and a y-intercept are our only possible dots. The x-intercept occurs with what would solve the numerator after we've canceled things out. So if we look back up here at our equation, I've canceled out these x plus 1, so those are gone. So what you see is negative 4 over x minus 2. There's no more x in the numerator, which means there is no x-intercept. That also should make sense because the x-intercept occurs on the x-axis, and we can't hit the x-axis because we have this asymptote right there. That is preventing us from having an x-intercept. All right, let's move along to the y-intercept. So this is going to be the only point we really have to shape our graph. The y-intercept is plug in 0 for whatever is left. I should have kept my arrow. Let me bring back my arrow here. We're going to plug in 0 for any x that's left. This is the only x that's left. We're going to put that 0 in the denominator there. If I do that, I would have, I'll just write it down here, negative 4 in the numerator, and then 0 minus 2 in the denominator, which is going to be negative 4 over negative 2, which is going to be positive 2. That means my y-intercept is at the ordered pair 0, positive 2. Okay, and that's the only point I really have to shape, so I'm just going to come in and use my asymptotes along with that 1 point. The rational graphs are in two parts. So we come over here, and there we are. All right, so there was a lot to that. You may want to watch that again. Try it, maybe try it on your own, and then watch it again. Number 4. Number 4 is already factored for you, which is nice, but I do want to start, just give you a little help on the horizontal asymptote. To find the horizontal asymptote, you need to compare the powers of x. But to compare the powers of x, we can't have it factored. We have to unfactor it. But you only need to unfactor the x's. What I mean by that is we're going to take the 2x times the x in the numerator, which gives you 2x squared, and in the denominator x times x, which gives you x squared. Now you're comparing the powers of x's. Because the powers of x's are the same, they're both x squared, we're going to have a ratio of their coefficients, which is 2 over 1. 2 over 1 is 2. So I will get you started. Your horizontal asymptote is at, I said x equals, no, is at y equals 2. All right, and it's already factored. So go ahead and cancel for your whole, whatever's left in the denominator is your vertical asymptote. Plug in x to what's left in your numerator to get your x-intercept. Your x-intercept will be a fraction on this one, so don't be alarmed by that. Okay, but I will let you finish that one on your own. Okay, moving on. So I am going to move relatively quickly through these because I know you obviously have the capability to pause them and rewatch them. So I'm not super worried about my speed, so I'm going to go pretty quick through these. And I am going to do the odd ones. So we're going to start with simplifying. To simplify, we need to factor. Factor first. Factor. So I'm going to factor a 10 out of the numerator. And so now this is my completely factored form. Before I cancel anything out, I want to list my restrictions, right? State any restrictions or excluded values. Okay, the restrictions are with the denominator. So what would make the denominator equal to 0? So p cannot equal positive 9. Because if I plug positive 9 in, that would make the denominator 0. Okay, now we cancel. P minus 9s go away. So our answer is just 10. And of course, we include this part in our answer as well, right? So that's part of our answer. But they don't need to be listed right next to each other. Okay, number 7, factor first. So that's going to be k plus 9 and k plus 1. Again, I would really encourage you to try to factor some of these without just letting me factor them for you. Factor them on your own first. See how well you're able to factor these. And then, you've got me going through them to help you kind of check them. All right, so the numerator is going to factor into k plus 9 and k plus 1, right? Two numbers that multiply to be 9, but add to be 10. Same thing in the denominator, two numbers that multiply to be 5, but add to be 6. Okay, list your restrictions. Those come from the denominator, so everything k cannot equal. So that's anytime you see a variable in the denominator, that creates a restriction. So I have 1, 2 restrictions. So that means k cannot be negative 5 and k cannot be negative 1. All right, let's start canceling. Grab a different color here. The k plus 1's cancel. So this simplifies into k plus 9 over k plus 5. So this is simplifying, okay? Now we're going to multiply. with number 9 and just number 9 here. So first thing we're going to do is, of course, factor. So looking at this first fraction, that numerator is v plus 6 and v minus 6. That's that difference of perfect squares. Anytime you see a letter squared minus something else, assume it's going to be this difference of perfect squares. Use your square roots. 9v times 1 over v plus 6. Okay, before we start canceling, like that 6. Before we start canceling, we need to list our restrictions. So v cannot equal anything from the denominator. So we've got a restriction here at negative 6, and we have a restriction here. Now this is not at 9, it's not at negative 9. What would happen if you set 9v equal to 0? Your restriction is actually at 0, because there's no plus or minus there. Creates a restriction at 0. Okay, now cancel. So v plus 6 cancels with v plus 6. Notice they're not in the same fraction, but one is from the numerator, one is from the denominator. Now that you've canceled everything you can, we're going to just look at everything that's left in the numerator and everything that's left in the denominator. In the numerator, I just have v minus 6 times 1, which is just v minus 6. In the denominator, I have 9v, and that's it. You cannot cancel this v with that v. Those do not cancel. Because the top v is wrapped up with that subtraction sign. So that's all we can do there. So this is our final answer, of course, along with our restrictions. Number 11. Number 11 is a division problem. So the first thing we're going to do is copy dot flop. And at the same time, I'm going to factor. So look at the numerator, because there's only one thing that needs to be factored here. This is the only piece that needs to be factored. So 6x squared divided by, and now I'm going to factor out a 9, which is going to give me x minus 3. So there's my copy. Change it to a dot, and then a flop. Now, I should have, and my apologies, and I make this mistake all the time. I didn't list my restrictions before I copied out flop, so I need to list my restrictions right away. So my restrictions come from this x, which we can notice also right here, and also from this x. Turns out they're the same thing, so we actually wouldn't have gotten it wrong, but oftentimes that would be a missing restriction. So our restrictions occur anytime we see a variable in the denominator, both before and after we copied out flop. So our only restriction is at 3, because both of these create a restriction at positive 3. So that's my only restriction. Okay, now let's start canceling. Do not cancel from division, only cancel from multiplication. So those go. All right, in the numerator, we just have a 6x squared. In the denominator, we just have a 9. Now, typically this is, I would see a lot of students stop right here. But we can reduce that 9 and that 6, which will reduce to 2 and 3. So our actual reduced one is 2x squared over 3. You could have done that over here if you would have caught it, recognized it. But I wanted to show you that even if you didn't, you could continue to reduce even after you kind of put them back together. All right, number 13 is already a multiplication, so we just got to factor. Ooh, that top one is going to be, it's a plus, so it's going to be minus 9 and minus 4. Right, because I needed two numbers that multiply to be 36. They have to have the same sign because it's a positive 36, but I needed them to add up to negative 13, so that means they're both going to be minus 9 and 4 is 13. All right, in the denominator, I'm going to factor a 2 out. And again, hopefully you're trying some of this without just watching me go straight through it, because just watching me go through it's not gonna get you where you need to be. All right, restrictions from the denominator. X cannot equal. Right here we have a restriction at positive 9. Sliding over here, we have a restriction. I oftentimes will see students tell me a restriction at 2. There's no letter here. That's just at 2. That doesn't create a restriction. It has to have a letter. The letter here creates a restriction at 4. All right. Okay, now we start canceling some things. Get a different color here for dramatic effect. Minus 9s will cancel. Minus 4s will cancel. And now I just have an 8 over a 2, which will make a 4. And this goes away, or you could say 1. And so this just reduces all the way down to 4, or 4 over 1. Okay, let's keep going. All right, I'm going to continue my theme of the odd problem. So now I'm over here. We're adding and subtracting. So we've got 3, 4, 5, 5 of those, and then we're into some solving. Okay, this one has common denominator already in number 15. So since it already has a common denominator, we're ready to just put them all together. So combining like terms, x and x is going to give me a 2x. And then we're combining a negative 2y and a negative 5y. So 2x minus 7y. At this point, we should try to factor the numerator. Nothing does factor here, so we're actually finished with that problem. Okay. Number 17 is not common denominators, so we need to get common denominators. When we look at 4 and 6, we're trying to come up with a number we could turn both of them into, right? So 4 and 6 can both be turned into a 12. So my next step, I want to make both of these fractions over 12. Now, what I'm actually going to do is make this plus a negative 6. In terms of the letters, they both have a u, so I need to include a u in my common denominator, but only just one u. It's not going to be u squared. If one of them had a u squared, then I would use u squared. Okay, now I'm trying to figure out what I need to multiply 4 by to turn that into 12, which would be 3. Notice where I write that. I'm trying to figure out what I need to multiply 6 by to turn that into the common denominator of 12. That would be a 2, and again, notice where I write that. Okay. On the left, I'm going to distribute 3 times u minus 3v. And on the right, I'm going to just take a negative 6 times a 2. Okay, next step, I'm going to keep them as 2 separate fractions, but I'm going to multiply this. 3u minus 9v, I just distributed, plus a negative 12 over 12u. Okay, combining like terms, let's see, there aren't any. So my common denominator of 12u, and now my numerator is 3u minus 9v minus 12. Okay, now try to factor that numerator. This is a weird numerator in that it's a trinomial. There are 3 parts, but it doesn't factor like a normal trinomial. But we can factor a 3 out of all of them. If I factor a 3 out, I have u minus 3v minus 4 all over 12u. And then my 3 reduces with my 12 to turn the 12 into a 4. And now my numerator is u minus 3v minus 4 all over 4u. And that's the completely factored and reduced version. So with adding and subtracting, this is where I see the most points lost from my students on the exam. The key here is we really need to show as many steps as we can. So don't just leave it blank, try. Okay, number 19. We do not have, or we do have common denominators here. So this is just to quickly combine them and put them over 12p plus 3. So on the left, we have a p, and on the right, we have a p. So we have 2 p's. And then we're going to combine the minus 3 with the plus 1. Minus 3 plus 1 is minus 2. So that we can factor that. So I'm going to factor a 2 out of there, giving me p minus 1. In the denominator, I can factor a 3 out, giving me 4p plus 1. And I factored that to see if I could cancel anything, but we actually can't. I thought I might be able to, but really nothing does cancel here. So we'll just leave it at that step. Okay. All right, another adding and subtracting one. Okay, so this one, in terms of a common denominator, this is a tricky common denominator. Common denominator here, and I'm going to make 2 fractions, is going to be 3a times a minus 4. I'm going to make that a plus a negative 2a again. Common denominator is going to be 3a times a minus. So if I don't have anything really in common, the common denominator is just the 2 denominators together. So fraction number 1 is going to need the a minus 4. Fraction number 2 is going to need the 3a. Okay, so I've got 5 times a minus 4 here, and then I've got a negative 2a times a 3a here. Okay, distributing 5a minus 20 is now over 3a times a minus 4 plus a negative 6a squared over 3a times a minus 4. Okay. Putting them all together, I have, and I'm going to write them in this order, negative 6a squared plus 5a. Whoopsies, pencils getting a little crazy there. Plus 5a minus 20 all over. Here, clean that up a little bit. 6a squared plus 5a minus 20 all over 3a times a minus 4. And we'll stop right there. We really should be trying to factor this denominator at this point. And while it might actually factor, I don't think it does. But even if it does, we're just going to leave it at that point because that's kind of a crazy one to factor. So we'll stop right there. That's not the best example, but it's not bad. Okay. 23, I believe, is a solid example here. We need to factor the denominators here. So in the world of adding and subtracting, we want to factor denominators first, not numerators. Although these numerators won't factor anyways. That's going to be x plus 5 and x plus 2. X over just x plus 2. Okay, so notice they both have an x plus 2. So that's part of my common denominator. My common denominator also has to have this x plus 5. So my first fraction is already over the common denominator, so I don't need to multiply it by anything. So I'm just going to rewrite it. But my second fraction, in order to be over the common denominator, we'll need an x plus 5. So I'm going to multiply that x times x plus 5 there. Okay, continuing on. First fraction doesn't change. Second fraction becomes x squared plus 5x over x plus 5 and x plus 2. Okay, continuing on. Now I'm going to put these two together. So when I combine up all my like terms, I have x squared plus 8x, and that 8 came from 5 and 3. Plus 8, right? Okay, now I need to attempt to factor that numerator to see if anything will cancel. But this numerator actually doesn't factor, which, again, is kind of odd. We should always check, try to see if it factors, and I think the one on the exam actually does. But at this point, we want to check to see if we can factor that. We cannot, so we'll just stop right here. Okay, on to solving. All right, so I'll just do 3 more here. I'll do 25, 27, and 29. Okay. Remember that you can use cross multiplication if it's fraction equals a fraction. We don't have any of those on this, but just remember you can use that. The ones here all have 3 fractions, so we're going to use this method of clearing the denominators. So let's clear these denominators. To clear the denominators, we're going to multiply everything by the common denominator. In number 25, the common denominator is 2n. Notice I write it above each one of them. And then fraction number 1, the 2's will cancel, the n's will cancel, the n's will cancel. Okay, so I have 5n plus, here I have 4 times 2, which is 8. Here I have 2 times 2, which is 4. Subtracting 8 from both sides. Notice no more denominators. I've cleared them. 5n equals negative 4 divided by 5. N equals a negative 4/5. There we go. We cleared the fractions. We solved the numerators. Ooh. Okay. So I'm going to factor these denominators. This one looks more overwhelming than it is. Honestly, it's not that bad of a problem. These denominators factor into p minus 3 and p plus 1. So all 3 of them have a p plus 1. And these second and third ones both have a p minus 3. So our common denominator is actually the p minus 3, p plus 1. And I'm writing these up here. You don't have to. If this method is not great for you, get rid of the p plus 1s. So here I have just a 1 times a p minus 3. So 1 times p minus 3. Both of these cancel. So equals just p minus 2. And both of these cancel again. plus p plus 4. Okay, so now I have p minus 3, again, no more denominators, equals 2p plus 2 when I combine some like terms. So then I'm going to subtract p here. So then negative 3 equals p plus 2, subtract the 2, p equals negative 5. There we go. Watch that again if you need. Okay. 29 is very similar. This is our last one. All right. 29 is very similar. So we are going to factor it first. This is going to factor into b plus 5 and b plus 1. That's equal to 1 over just b plus 5 minus, and we can make that plus a negative 5, plus a negative 5 over b plus 5, b plus 1. Okay, our common denominator is that b plus 5, b plus 1. Let me just show you another method here. The first and third, right? The first and third fraction already have the common denominator. The second fraction is missing b plus 1. So that's really the only thing that's going to end up being needed or multiplied. So everything's wiped out here. And so we just have 1 equals b plus 1 minus 5, or plus a negative 5, however you want to say that. 1 equals b minus 4, adding 4. Looks like b equals 5. Okay, so I just did a lot of problems for you. Rewatch the video, rewatch any questions you need, try some of them on your own.